Welcome back to the Best Writing on Mathematics channel. In this video, I will give an overview of the 2015 edition. That was the 6th anthology in the series of Writing on Mathematics selected from professional journals, general interest publications, and internet resources. All pieces in that particular volume were first published in 2014 calendar year. Most of the volume is accessible to readers who do not have advanced training in mathematics but are curious to read well-informed commentaries about it. Michael Barany and Donald MacKenzie locate the center of the mathematical activity done in institutional settings and occasionally in private homes at the blackboard. They note that blackboards are key objects that influence the organizing of the research and teaching spaces, while chalk writing on blackboards influences the logistics and the overall manner of mathematical communication. Pradeep Mutalik finds that the repeated experience of feeling right when we suddenly comprehend the solution to a problem or a puzzle has had a positive evolutionary role in defining us as humans, both cognitively and emotionally. Cole Mulcahy and Dana Richards write an informed centennial appreciation of the life and work of Martin Gardner, that remarkable polymath who inspired many mathematicians and laypersons to take up mathematical games and similar challenges. Arthur Benjamin and Ethan Brown teach us how to construct an unlimited number of customized magic squares by improvising on a few ingenious templates. Toby Walsh starts with a popular Candy Crush game as a guidepost for his discussion of the factors that determine the difficulty of solving computational problems in mathematics. Marianne Freiberger takes us to the billiard room. She explains how the trajectory of a ball rolling on the pool table leads to mathematically complex problems related to chaos theory, the conductivity of metals, and other infinite surprises. Eric too models juggling numerically to show that it is mathematically similar to the morphing game of transforming one word into a very different one by incremental steps that admit changes of only one letter at a time. Scott Aaronson dissects the intricacies of the notion of randomness and connects it to the study of paradoxes, complexity, and quantum mechanics. Dana MacKenzie describes how biologists, physicists, and mathematicians interacted to overcome theoretical obstacles encountered in the birth and growth of synthetic biology. In a similar vein, Natalie Volchover describes the interdisciplinary efforts undertaken by researchers interested in the Tracy-Widom distribution associated with phase transitions in interactive systems of various types. Eli Maurer and Eugene Jost present and illustrate beautifully the basic geometric properties of the logarithmic spiral, cycloid, epicycloids, and hypocycloids, some of the best-known curves studied over the centuries in connection to natural phenomena and physical motions. Burkhard Polster analyzes the mathematical properties of several non-circular shapes of constant width and shows us how they have been applied to various gadgets and playful devices. The quickest way to summarize the brief article by Annalisa Cranel, Mark Franz, and Fumiko Futamura is to say that they look at Dürer's perspective drawings from several different perspectives. Weihart and Henry Segerman ask whether there are groups of symmetries that can be visualized using real-life objects but have never been represented as such, and propose a novel modeling of the quaternion group. John Conway and Alex Riba use wordplay and a humorous ingenuity to discuss the merits of several different proofs they give to an old geometry problem that looks deceptively easy until you try to solve it, that is. Gilla Hanna and John Mason discuss the many facets, relative merits, and theoretical pedigrees of various terms used by mathematicians or mathematics educators to qualify the worthiness of proofs, with a main reference to a similar attempt by Timothy Gowers. Jim Fay, Saul Garfunkel, and their other co-authors, Diane Bryars, Andy Isaacs, Henry Pollack, Eric Robinson, Richard Schaeffer, Alan Schoenfeld, Kathy Seeley, Dan Teague, and Salman Usiskin formulate 5 tenets they consider important to be taken as guiding principles for the mathematics education reform at high school level in the United States. Gui Li Zhang and Miguel Padilla compare multiple aspects of mathematics instruction in China and the United States based on previous theoretical and empirical studies. Against commonly held wisdom, Benoit Ritaud and Albrecht Hiefer argue that the pigeonhole principle, usually attributed to Dirichlet, was stated in writing at least 2 centuries earlier in Selecta Propositiones, a book by Jean Luréchon. Lisa Rougetet traces the earliest written descriptions of the popular game of Nim to a treatise written at the beginning of the 16th century by Luca Pacioli, and follows the subsequent European developments of the game since then. Jan von Plato considers the context of mathematical ideas and the personalities that shaped German mathematician Gerhard Jensen's ordinal proof theory, and how this work relates, or maybe does not, with a theorem by Reuben Goodstein. James Franklin illustrates with several well-chosen examples the local-global synergy in mathematics, one of the many conceptual polarities that characterize mathematical thinking. Carlo Cellucci reviews many opinions on what constitutes mathematical beauty and its role in mathematics. He concludes that aesthetic factors play an indirect epistemological role in discovery via their selective role in choosing what hypotheses to consider. Mark Balaguer argues that philosophers of mathematics are mainly concerned with the meaning of mathematical discourse, and that the semantic theories they adhere to can lead to claims hardly acceptable for the mathematicians. Stephen Strogatz discerns three broad types of rapport with mathematics in the general public and tells us how he honed his talent for writing about mathematics by paying attention to the writing qualities of masters in similar trades. Domenico Napoletani, Marco Panza, and Daniele Struppa examine the methodological underpinnings and the philosophical implications of using ever more powerful computing techniques in the modeling of complex phenomena. Andrew Gellman and Eric Loken caution that evidential claims of statistical significance in research journals are often spurious because of multiple factors related to the gathering of data and its interpretation. They give several suggestive examples to that effect. Jeffrey Rosenthal tells the true story of how his statistical expertise led to the discovery and prosecution of fraudulent lottery winnings in Ontario, Canada. Finally, in the last piece of the volume, David Hand explains a bias of expectations that precludes us from perceiving the increased likelihood of coincidences following the rapid combinatorial growth of possibilities that comes with the increase of the number of simple events. Besides these texts, the volume also included a long list of also-rans, a list of interesting pieces that for various reasons I could not include in that volume. Thank you for listening to this video in the Best Writing on Mathematics channel.